This is the Millennium Development Goals Challenge to resolve hunger and poverty in Morocco. So first, the Millennium Development Goals are a set of goals that the organization strives to address each year. These are all serious issues on a global level, and the MDG does its best to reduce these by providing long-term sustainable solutions. The issue that this presentation is going to focus on is the issue of extreme hunger and poverty in Morocco. So to define this problem, there has been current research and development actually on this topic in Morocco, and it was found that 4 out of the 32 million person population in Morocco lives below the national poverty line. Also, 3 million of those 4 million are located in rural areas. And a lot of the poor are found in the rural areas and not on the coast, because people on the coast have a lot of access to water and also turn fish to eat. In the rural areas, the problems with food and poverty come from lacks of water, quality soil, and natural resources. There are also many current technologies and policies in place to resolve these issues of hunger and poverty. One is the Tangier Med Port. This was constructed in Morocco for $90 million, which is about 95 million US dollars. This promoted investment in tourism, industrial, fishing, and service industries, and created jobs in each of those fields. The solution was also used to enhance global trade with areas including Western Europe and North America. So the solution that's going to be proposed with this presentation needs to be one that is a new technology, something innovative. Also, when dealing with a developing nation like Morocco, you need to come up with a solution that's cost effective and something that will be able to last a long time without harming the environment, the society, or the wallets of the people of Morocco. So first, here are some of the constraints keeping the people of Morocco in poverty and keeping them hungry. First is non-irrigated land. There could be a solution for this with a tilling tractor, but this is very expensive and unlikely to be afforded by the people of Morocco. Some other problems come from old seeds and outdated farm equipment. Also, the techniques that they use, due to the lack of equipment they have, are not the strongest and aren't kept up to date with the rest of the world. Also, the plants and crops are contaminated due to dry, unirrigated land and improper treatment. And also an issue is unemployment, because the agricultural sector is so small and people that farm basically do to feed themselves. So the design that's going to be proposed is very similar to this machine here shown. It's a little blurry in the picture, but this is a walking tow machine. You just basically start the engine and then you push it. It's got supports on the outside, and then it's got blades all throughout, so that whenever you push it along, it tears up the land underneath. It has a 6.5 horsepower engine, which is going to be similar to the proposed solution, which is going to follow. So the watering till is the proposed solution. Basically the same as the walking till, except it's going to have a watering component, and you'll be able to vary the amount of water that you let out while you till the land. So this is the axle of the watering till machine that's being proposed. You can notice that the wheels are 2 inches smaller than the blades. This is so that when you push it along, the blades actually dig into the ground while the wheels stay on the land on the side. You can see it's 26 inches long, which is 2 inches longer than the housing, and the blades are 6.7 inches apart. This next figure is the engine and gas tank housing. There's a slot in the middle that's going to hold the 6.5 horsepower engine, and around the outside is going to be the gas tank, the ring around the outside, and the axle. You see the 1 inch diameter hole at the bottom. when the parts would come, the wheels wouldn't be on the axle yet, so you could feed either end of the axle through the ends of the housing, and then put the tires on from there. Also, notice the notches on the top with the drilled holes in the sides. That will be used to house the next portion of the watering till, which is the steel plate. Now it's shown upside down in this picture, but basically, if you flip this over, the angle iron feet of the steel plate are going to go into those grooves on the edges of the top of the housing, and then be drilled into place. This can just be done with screws, so that whenever you need to refuel or do any maintenance with the engine, it's really easy to take off. The angle iron is 2 inches wide and travels 2 inches onto the plate that is 2 foot by 2 foot. So next is the 5-gallon water bucket. This is going to sit on top of the steel plate and be supported by the weight of the water itself. These are dimensions of a standard 5-gallon bucket, 10.5 inch diameter, 18 inches in height. And at the bottom, if you notice, there's a 1 inch diameter hole. This is going to be used for the watering component of it, so that a hose would go into that portion and then come out, and there would be a valve on the end of the hose. So depending on how dry your land is, you can either crank it all the way open or just halfway if it had just rained. Okay, this is the final piece. It is the handle or the frame of the watering till. It's 38 inches long and basically operates like a lawnmower handle. If you notice up toward the top, in the top right corner, there is a groove cut in the inside of the rail, and there's a handle that's 1/4 of an inch thick that would be able to slide up that groove and basically initiate the engine and get the blades spinning when you squeeze it. This is a very easy way to operate this machine. It's basically being able to tear up the land with just a squeeze of your fist. So the walking till that was shown earlier runs about $250 to $280, and basically the only difference from that to the watering till is the watering component with the bucket, the hose, and the valve. So an estimated cost for this product would be $280 to $310. Like I said, it's very simple to operate. Basically, just like a lawnmower, you just go along the land and all your land gets watered and torn up as you go. So as stated earlier, the solution needs to be sustainable on all levels. So the first sustainability assessment that I'm going to go over is the economic. This equation here shows the net present value. It's a very important value for any product, and it should be performed for any project. Basically, the net present value is equal to the initial cost plus the sum of maintenance costs with a given inflation rate and discount rate over the lifetime study, which is N. So for the environmental, actually, let me go back for a second. Okay, so the MPV was calculated for an initial cost the initial cost was $310 because this was in the middle of the price range. The maintenance cost was $150. This was chosen because you get about 50 uses out of it a year, and gas runs for about $3 a gallon. That's why $150 was chosen for maintenance cost. And then standard inflation rates and discount rates of 1% and 5% were chosen. And also this product would have about the same lifetime as a lawnmower, so about 10 years would be a good point to use. used for lifetime. So when all these values were plugged into the net present value equation, it was found that from the initial cost after 10 years of use, the cost of the product only went up by $100. And the net present value after 10 years was $411. So that just goes to prove that this is an economically sustainable product, because even after 10 years, you only have to put $100 into it, basically just the fuel. Okay, so the next sustainability assessment was the environmental assessment. This was done using a software called EIO-LCA, and basically, this is all it is right here. You pick a sector. I typed in agriculture, and this came up, so I picked the most relevant one to my product. And then, using this net present value, I divided it by $1 million to find out the amount of economic activity for one of them, which was 0.0004 million. And the category that I would like to see is conventional air pollutants, because this is an environmental analysis, and I want to see whether or not the atmosphere is being harmed by air pollutants. So this is the table it gave me back. And with such a small product like the walking watering till machine, I didn't expect to see many emissions. Throughout the whole sector though, there were some emissions, but for the specific sector that I'm worried about, which is agriculture and forestry support activities, there was 0.006 parts per million of carbon monoxide. So virtually nothing bad would come from this small product. And a societal assessment also took place. Basically, this product would have a positive impact on all that it affected. First off, for the food, increasing the quality of the land would in turn increase the quality of the food. People would eat better food, live healthier lives. And also, better food would be better business. Better food at a higher quantity would be made with an efficient solution like this, and be able to be sold at markets and really get the agricultural business going in Morocco, something that needs to be done in all developing nations. And also this would open up trade. Material requirements for this, there are many metal ores that are mined in Morocco, so these can be traded overseas and then made custom to create the parts of the watering till, and then traded back as completed parts, and then maybe even get trade out of the food that is created by the watering till. But it could do nothing but start to generate business and get money and food flowing both in and out of the country. Also, it has a positive impact on the way of farming. Rather than walking down, doing it all by hand, raking your land, tearing it up by hand, and watering it by hand, this would be a much quicker way to get a larger quantity of land tilled in a shorter amount of time. So, in conclusion, the watering till could be a breakthrough in technology, especially for developing nations. Obviously, agriculture is very important, as in research and development showed that 75% of the rural poor population has to rely on agriculture for a living. So it's not like American farms where they're farming to serve other people or to just make money. They're farming to live. So a technology like this would be very important to the lives of Moroccan farmers. Also, it's a breakthrough in technology on an individual level, just because it's a very efficient product that can get the job done that would normally take all day in a short amount of hours. So, hope you enjoyed the presentation. This is the watering till machine, and hopefully it strives keep being taken to end hunger and poverty in the country of Morocco and all over the developing world. Thank you.